The scientific revolution starts now.
This is the Spacetime podcast.
Let us see in the dark.
Over the last, year or two since we had you on last, we've had the chance to sit with a lot of different consciousness researchers, psychologists, everything, Jungian psychoanalysts, and it's been interesting to try some of your ideas on in those conversations. In particular, the conscious summing agent model, which doesn't always make it into a lot of these other podcasts, and I think that's something that I'm really, really excited about too, and it's been fun to try bouncing those ideas off other people and making headway. So anyways, yeah, welcome back. I'm excited to explore these things further, and yeah, maybe you can just tell us what you've been up to as far as advancing these thoughts in the last year or so. What has your desk been looking like lately?
That's a great question, and thank you again for your kind invitation. It's great to be back here and to talk with both of you. Yeah, so the last year has been quite interesting. What we are doing is, well, first we're paying attention to what many high energy theoretical physicists are saying, which is that space-time, which we have assumed to be the fundamental framework of reality, and that objects in space-time are the fundamental entities of reality, that framework seems to be limited. And many high-energy theoretical physicists are looking for a new, deeper framework, entirely outside of space-time. Not like string theory that's got dimensions curled up inside space-time, but entirely outside of space-time. So they're looking for new structures. By the way, successfully, they're finding new mathematical structures outside space-time that allow them to actually do real physics inside space-time, like predict scattering amplitudes of particles in colliders and so forth. So in the last 10 years, they've been making all this incredible progress. And we realized that we're proposing a theory of conscious agents outside of space-time. They're not. So this is not a physicalist theory. It's not that certain particles inside space-time have consciousness or certain objects inside space-time have consciousness. It's not a theory like that. It's saying, here's a new ontology. The fundamental nature of reality is a network of conscious agents outside of space-time. But we, of course, to do science, need not only to make that theory mathematically precise, but we need to predict stuff inside space-time, like scattering processes and colliders. And so we realized, wow, what the physicists have done in the last 10 years is the gift that we need to help us make the map into space-time. So we needed to take our conscious agent dynamics, which is outside of space-time, look at the structures that the physicists have found outside of space-time, and say, can we connect? Can we connect with those structures? If so, then once we've made that connection, they take us into space-time, at least part way, right? They'll be the first to tell you that they have a lot more work to do, but they have done some work, and they can get you into space-time for certain kinds of classes of particles. And so we realized, well, that's a specialist job anyway. It's unlikely that we're going to be able to figure out what the physicists haven't figured out, how to get those particles from outside of space-time. So we decided to plug in to what they're doing. So in January, we published a paper, which is called Fusions of Consciousness. So if anybody wants to get technical, they can go read the paper. It's called Fusions of Consciousness. It's at the journal Entropy, came out in January. And there we go through the mathematics of our conscious agent dynamics. And then we make a connection, a specific connection with one of the structures that the physicists have found outside of space-time. The deepest structure they found is something called decorated permutations. And they're surprised that that's what they're finding. So they didn't expect it. But so permutations are like reorderings. If you have a bunch of cards, right? If you have 52 cards in a deck, there's lots of ways that you can shuffle the cards and get a different order. And each one is a different permutation. So the mathematicians look at permutations. And decorated permutations are a special kind of permutation. if you're interested, we can go into the technical details, but I'll just leave it at that for now. But if you decide you want to, we can go into the details of what is a decorated permutation and how it's different and why it's important. So then our dynamics of conscious agents is Markovian. So it's a probabilistic dynamic. I'll just say it's a probabilistic dynamics based on Markov kernels and Markov chains. And so we said, well, what we need to do is to map Markovian dynamics onto decorated permutations, right? If we can do that, at least we will have the beginning of a bridge. It's not the whole story, but we'll have at least a beginning of a bridge from our theory of consciousness through decorated permutations, perhaps into particles in spacetime.
Maybe we can take a brief detour to explain
Sure.
what it means to take Markovian dynamics and to map them onto decorated permutations.
Right. So in a Markovian dynamics, I'll give you a concrete example. Suppose that there's some conscious entity that can only see red, green, and blue. That's all it experiences. 3 colors, red, green, and blue. And there's a certain probability. If I see red now, what's the probability that I'll see blue next or that I'll see green next? And same thing for green. If I see green now, what's the probability I'll see red next or blue next? So you can write down a little 3x3 table, right, of all those probabilities. If I'm seeing red, maybe I'll see red next, maybe I'll see green next, or maybe I'll see blue next. Then for green, maybe I'll see green next, maybe I'll see red next. And so you can just write down a 3x3 table of all those probabilities. That's a Markovian kernel. That's all there is to it. It's that simple. So it sounds really fancy and so forth, but it's just a table of these probabilities. But mathematically, you can think of it as like an operator. It can actually do things. That table of probabilities can actually do things, 2 vectors.
And so it sounds basically like the challenge here is to construct a sufficiently information-dense table that contains all of the possible things that are probabilistically playing around in the given moment. And is that where the permutations come in? Is that the arrangement of the various things that could be happening?
Close. So what we have to do is look at all possible such tables, right? Because we're looking at, we don't want to put any straitjackets on consciousness. So anything that's probabilistically possible, we have to allow. So we have to look at the set of all possible such. So I gave you one little table, but it turns out for the one that I gave you, this 3x3 matrix, if you look at all the possible such matrices, they form a geometric object, right? This geometric object it's a 6-dimensional object. Think of it like a diamond, but it's a 6-dimensional diamond, and it's sitting in a 9-dimensional space, and it has 27 sharp points on it, 27 vertices on it. So it's a really complicated thing, and this is one of the simplest, right? One of the simplest that when you go to 50 colors, for example, the number of points on this diamond, there are more points on the diamond than there are particles in the known universe. So with just only now you can perceive millions of colors. So 50 colors is trivial, but by the time this conscious dynamics is dealing with just 50 colors, the geometric object that describes what consciousness could do is so complicated that even just the little points on it are more points than the number of particles in the known universe. That doesn't include all the other structure, which is even more complicated. So it's pretty. It's.
Let me ask you a stupid question. Do the probabilities of those different colors, don't they depend on the environment that hypothetical conscious agent is living within, right? If it's in a forest, maybe it's going to see more green. If it's in a lava field, maybe it's going to see more red. Are those features, how does the environment factor into this?
That's right. The environment figures in that it's a big social network. So it's not just one conscious agent. There are countless conscious agents interacting. So think the Twitterverse, right? So there's each Twitter user might be following a certain number of other users and tweeting out to their followers. And so what you see depends on who you're connected with in the Twitterverse, and that will influence what you decide to follow or what to tweet or retweet or whatever or comment on. So there's this vast that analogy is quite apt. our Markovian dynamics really is a vast social network that you can describe with Markov chains. So that's the way to think about it. So you're absolutely right. What you're going to experience is sort of going to depend on the clique that you're in, right? Which group, who are you following, who's following you, what kind of interactions you have. So if I were in China, for example, with a group over there, I might have a very, very different Twitter experience than if I'm in Arizona or in Bali, so very, very different.
And the very simple form of that would be, I can only see 3 different types of tweets, something like that. Like I see tweets that are affirming my worldview or disaffirming it, or tweets that, I don't know, just 3 categories you could think of, but you would only have 3 options essentially, and they're contingent in some sense upon how you interact with the community.
That's right. So if you're a Twitter user that has decided to put certain filters, I only want to see stuff of this kind, that might correspond to one of these conscious agents that might only see red, green, or blue. But then you might have another agent that can see, 5 million colors. So there's no limit in the mathematics. The idea is to have a general theory for all possible kinds of consciousness.
Okay, and so you have these Markov kernels, which are probability matrices of what comes next after a specific event, and then you're mapping them onto these decorated permutations. Can we have at least something that we can think of in terms of decorated permutations so that the explanation doesn't start to get away from people?
That's right. So what we found was, we thought, this seems like a pretty natural mathematical question, so surely it's been done. And so we went and did a literature search, and no one had done it. So we did it. So it was apparently a new contribution to mathematics. And what we found was the right way, or a natural way, a very natural way to map. So we're not mapping a specific, we're not just interested in one specific kernel, right? We're interested in the set of all possible, right? These big spaces I'm talking about with all these points and so forth. So we're mapping from that whole space, and we're taking collections of kernels and mapping them onto decorated permutations. So this collection will get a particular permutation. That collection over there will get another permutation, and so forth. And the idea was, if you think about a social network, you might have the big social network like the Twitterverse. You might be able to divide it into little groups. Right? These people only talk to themselves. They don't really listen outside themselves, and they only tweet. So they only listen and tweet to people in their clique. Okay, and of course, there could be cases where it's almost exactly that way, but maybe 1 or 2 people are tweeting outside, right? So you could have these coherent groups that are completely isolated and insulated, or there could be various degrees in which they have small contact with other groups. And it turns out that the decorated permutations are a way of describing these groups. What are the cliques? What are the groups? So, and that was the surprise. So that then told us, okay, it's the cliques that are the thing that are going to be of interest in mapping into perhaps particle physics. So that was one of the things that appeared to us.
So is that kind of a sense of local realism almost? I mean, I know that we're talking outside. You're saying that this lies outside of space-time, but it seems like the implication is that there are regional interrelationships that then can be modeled as having a specific set of interactions, and that specific set of interactions is massive. Like you're saying that it has all of these mathematical dimensions to it that means, for as far as I can understand, that from any given point inside of this matrix, you can get to a lot of different locations depending on the mathematical operation that you perform. Is that?
That's right. Yeah, I would say so. But in terms of local realism, so local realism in physics, right, is the claim that realism is the claim that particles have definite values of their properties like position and momentum and spin when they're not observed. And locality is the claim that particles have their properties have influences that propagate no faster than the speed of light through space-time. And the Nobel Prize in Physics last year was given for experiments by John Clauser and Alan Aspect and Anton Zeilinger, who over decades showed pretty strong evidence empirically, strong enough for the Nobel Committee, that tend to make us think that local realism is false. So it's false. that an electron has a position when it's not observed, or definite value of its momentum, or so forth. And so now, so your question was, am I proposing something like local realism, that there's some kind of reality here? So our theory is completely compatible with what the Nobel Prize Committee just gave the prize for, which is that for physical properties, local realism is false. All physical properties are not there, position, momentum, spin, and so forth, have no definite values when they're not observed. Because again, our conscious agent dynamics are not physical particles. They don't have a momentum, they don't have a position, they don't have a spin. They're not physical. So they're entirely outside of the very language of space-time, including the language of position, momentum, and spin, and so forth. But that dynamics projects into space-time, or what I should say, that's what we're working on. This map with decorated permutations is us trying to get the map into space-time. So the idea would be that the reason why local realism is false inside space-time is that space-time is a tiny, trivial projection of a much more complicated universe of conscious agents outside of it. So it's only when, the way I think about it is, the Twitterverse is so complicated. There's millions of users and billions of tweets. There's no way that you could grok the whole Twitterverse and know everything that's going on, or talk with all the users. So what do we do when we're overwhelmed with like social media or whatever? We use interfaces. We use like for example, your computer is way too complicated to interact with. So instead of toggling millions of voltages to send emails, you have a little desktop interface that sort of hides, it covers up the incredible technology in your laptop, and you don't have to know about it. And you're glad you don't have to know about it, because it's just way too complicated. And yet you use it successfully because you have this dumbed down user interface that lets you interact with that complexity, but doesn't force you to understand that complexity. So that's what space-time is. It's this really dumbed down interface. Right? For 50 colors outside of the interface, there's this world of possibilities where just the number of points in the possibilities is greater than the number of particles in the known universe. So, and that's just 50. By the time we get to millions of colors, what the complexity of our visible universe is basically zero compared to that. Basically zero complexity compared to what goes on beyond it. So that's what's going on. The reason why local realism is false in space-time is that space-time is this really trivial headset. It's a trivial interface to a much more complicated world. And so the fact that we're losing all this information in the projection from consciousness into space-time is the reason why local realism is false. There is a reality outside space-time, but it's not. But the language of particles and position and momentum and spin is just entirely the wrong language to describe that realm.
And so what is the language to describe that realm? Is it a realm that can be described? Because go ahead.
Yeah, I mean, I want to unpack the triviality of space-time, but maybe we can take our time getting to that, because I still don't understand, or, well, maybe I understand, but I want to make sure everybody follows why people were working on these decorated permutations in the first place. Like, why was this already an intriguing route to physicists? In other words, you made the claim, and you've made it on other podcasts, that
space-time is doomed.
Space-time is doomed, yeah. And I want to make sure everybody's on the same page about that before we investigate the triviality of space-time with respect to perception and conscious processing and all of this.
I think that's fair.
Right. So the reason why many physicists, and the ones that I'm talking about are a branch of physics called high energy theoretical physics. So and that's not most physicists, right? This is a small group of physicists whose specialty is this area of physics, high energy theoretical physics. And so David Gross, Andrew Strominger, Nima Karni-Hamed, and others like them, and Nathan Seiberg, have all indicated. So these are like some of the experts in high energy theoretical physics, some of them at the Institute for Advanced Study at Princeton or Harvard and so forth. So they're not, they're, in terms of all physicists, they're a small minority, but they're the minority that counts, because this is their field, this is their bailiwick. And so what the argument is quite straightforward. If you want to look for smaller and smaller things with higher and higher resolution, then you need to get a more powerful microscope, right? And what does the more powerful microscope do? It lets you focus smaller and smaller wavelengths of light effectively on the object that you're looking at. You need small wavelengths of light to resolve small details in whatever you're looking at. And that's fine. I mean, quantum mechanics doesn't have any problem with that. You can make your wavelengths as small as you want. But when you bring gravity into the equation, there's a problem, because quantum mechanics tells us as the wavelengths get smaller, the energy goes up, right? E equals h nu. Actually, that was Einstein that told us that in 1905 in his paper on the photoelectric effect. So E equals h nu. But then Einstein also tells us in his 1915 paper on gravity that energy and mass, well, he tells us that in 1905, but also in his 2015 paper, energy and mass are the same thing. But then he tells us in 2015 that mass and energy curve spacetime. And here's the kicker. As you put more and more, you get the energy higher and higher to get the smaller resolution of your light or with the radiation. The energy at some point, or the mass that it equals, is so big, so much energy, so much mass in such a small region of space that you create a black hole. So you then destroy the very system you're trying to measure. I'm trying to measure, something about an electron or a quark or something like that. At some point, you're going to get so much energy in such a small region of space that space-time itself ceases to have any operational meaning. You create a black hole. And if you try harder, like I'm going to make even a smaller wavelength of light, the black hole just gets bigger and bigger. So what this means is just a one-line summary then. Space-time has no meaning beyond 10 to the minus 33 centimeters or 10 to the minus 43 seconds. You can use space-time very nicely for smaller and smaller scales until you get to 10 to the minus 33 centimeters. And then all of a sudden, space-time throws up its hands and says, I can't help you anymore. And for me, I think of that as extremely shallow. It's 10 to the minus 33 centimeters, not 10 to the minus 33 trillion centimeters, just 10 to the minus 33. So my feeling is we have a fairly cheap headset. We got only 3 dimensions of space, 1 dimension of time. It falls apart at 10 to the minus 33 centimeters. I want a refund. This is a cheap headset.
And so folks are having more success with different mathematical frameworks. It sounds like what you're pointing to, these folks at the Advanced Institute and so forth.
Yes, what they're saying is if we thought, so space-time, of course, is very useful for everyday physics. It's an extremely useful framework. No question about it. But if we thought that space-time was going to give us the fundamental theory of everything, absolutely not. It can't even talk about stuff beyond 10 to the minus 33 centimeters. It just can't even, it has no language to discuss that. So it's from that point of view, it's going to have to emerge now from something deeper. And so the physicists are looking, many physicists are looking in many different directions for what might be this deeper realm outside of space-time, from which space-time might emerge. And I think the most promising are these approaches in which the physicists say, we can't go halfway here. We have to jump entirely outside of space-time and quantum theory. So we need to just come up with new mathematically precise structures outside of space-time, but with the proviso that those structures ultimately have to project back into space-time precisely because space-time right now is the only place where we can do our experiments, right? So if you're going to test your scientific theories, right now we have to test them inside space-time. Maybe later on we'll be able to figure out how not to do that. But right now we have to test them inside space-time. So we better take these new, deeper structures, project them back into space-time, and show that in their projection, we get back the standard physics that we know and love, like quantum field theory and Einstein's theory of gravity and so forth. We need to get those as special cases of this deeper dynamics. So they're projections. So that's what the physicists are up to, is showing that these deeper theories do project to something interesting inside space-time. And they give you the right numbers. They give you the right scattering amplitudes for when 2 gluons smash into each other and 4 gluons go spraying out. So they do good work. So it's not like we're saying, oh, well, space-time, that can't do 10 to the minus 33 centimeters. Well, that means we can do whatever we want. We can make some brand new theory. No. You don't get to make any brand new theory you want to. You better make a theory that projects and gives us all of the results that we have inside space-time and matches them exactly, or explains why yours are better, and give us experimental tests. So this is very, very, trying work. You have to be very, very precise, and you have to be exactly right in your predictions.
Are you watching the Demystify Sci podcast and wondering, what can I do to support this absolutely incredible project? Well, wonder no more, because you can come on over to patreon.com/demystifysci and sign up to give us a couple dollars a month. Might not be a lot for you, but all of those donations add up, and they let us push this project to even greater heights.
What is their starting point if they're not working off of the canonical framework? How do they even start to conceive of the universe in a different way and then try to work back towards the emergence of space-time? I mean, are they working with the same kind of variables, these like frequency, mass, energy, the same ideas, or do they have a completely new framework for approaching the physical universe? I'm just curious how you even start outside of such a well-accepted framework.
Well, you can imagine that this is incredibly challenging, and the people doing it are up against an incredible task, and they have to be pretty bright to do it. The kinds of things that they're doing is, well, first, they're not only letting go of space-time, they're letting go of quantum theory. Mm-hmm. For example, Nima Hamed at Institute for Advanced Study at Princeton is doing that, and many of the collaborators that he has. The idea is that all the weirdness of quantum theory, no cloning theorem, you can't clone quantum bits, superposition and entanglement, all the standard weirdness of quantum theory is merely a consequence of loss of information. When you have incomplete information, it turns out you can show that when the states of knowledge, so your epistemic states are missing knowledge, missing facts, then you will have this no cloning theorem, you will have superposition, and so forth. And so, in other words, quantum theory itself is also a symptom that space-time is just a headset. It's got only partial information. But of course, now the physicists aren't saying space-time is a headset. That's me. So I'm not putting those words in the physicist's mouth. I'm saying it's a headset. They're just saying that there's limited information inside space-time, and therefore quantum theory itself is also doomed. It can't be fundamental. So they're looking for a deeper structure that will give rise to quantum theory and space-time together, so to speak, joined at the hip. They arise together. And what they're doing is they're asking themselves, what kinds of structures outside of space-time could we posit that would give us mappings into space-time? And so they're it's a tough challenge, because you have to say, can we take clues from the structure of quantum field theory, unitarity and so forth, and locality? Is there some way that we can take clues from those? But ultimately, space-time can't tell you what to do, right? What you'd have to have are these geniuses that are taking creative leaps, and of course, most of your leaps will be wrong. But every once in a while, you get a leap that isn't as wrong, and you can start to work with it. And so what they found, Nima Hamed and Jaroslav Trinka published in 2014 a paper about the structure called the amplituhedron. So that paper was published about 10 years, so it's less than 10 years. So it's fairly new stuff. And this structure is outside of space-time. So you can think of it as it's not like a diamond. It's not a polytope. It's actually, it goes off to infinity, potentially. So it's a big structure, and it has no Hilbert spaces. That means there's no quantum theory here, right? So this is not we're not trying to boot up space-time from quantum theory with this approach. So there's no Hilbert spaces here. There's no quantum theory. There's no locality. So there's no Einstein special relativity here. But you find that what they found is that the structure of this geometric object is the amplitude is a geometric object, and its volume codes for probabilities of particle interactions, what they call scattering amplitudes. But those scattering amplitudes just mean what are the probabilities that particles with these momenta would interact in this way at the collider. That's what those scattering amplitudes are. And the volumes of these amplituhedra give you those probabilities, which is really quite amazing. But the volume, but the structure itself doesn't care one bit about locality, in other words, space-time, or unitarity. That is, it doesn't care about quantum theory. But it does, as sort of a side effect of its own geometry, in the structure of its facets and points and edges and so forth, it does allow you to see where locality and unitarity arise from the structure. So you can get the projection into space-time. You can get those properties from a structure that really transcends space-time, and it transcends quantum theory. So that's what you would hope for, is that, right, if we're going to go outside space-time, of course, first, we're going to have to take a lot of guesses and probably be wrong, but whatever guesses are going to have to be pretty interesting, and they have to give us back locality and unitarity, as projections of this much deeper structure, and that's what they're finding.
So when when we start talking about the triviality of a space-time, is that just because space-time is only one consequence of this higher ordered relational system? Like there could be other, I don't know if you want to call them realities or conscious realities that are not that one particular solution to it. Because obviously if space-time falls out of it, it is, I don't know, I wonder how you arrive at the concept of triviality, because it seems like it's a pretty important consequence at the same time. But if it's not singular, then I think that I understand.
That's a wonderful question, and so I'll be just a slightly more technical with the amplituhedron now. So to specify an amplituhedron, you have to specify three integers, n, what they call n, k, and m. Then you have to also specify a collection of momenta that they label z. Okay. So I won't go into what if you're interested, we can of course go into what n, k, and m mean and all, but I'll just focus on the m. It turns out that the m is essentially the dimension of the space-time that you're going to project into. So ours is 4, m is 4. But the amplituhedron allows you to have 8, 15, a trillion, quadrillion. In other words, our space-time is one of the smaller numbers. It's one of the more trivial interfaces that you could build an amplituhedron for. So already in the very first structures that we're finding outside space-time, what we're finding is that there's one little small valued parameter that happens to correspond to our space-time. It's just 4, but our theory allows us to go to any big integer you want. So already I feel again cheated. We got number 4. We didn't get 10 or 20, or what about 10 million or 20 billion? There's lots of bigger m's than 4. So I mean, who was being cheap?
But there's something about math that allows you to map it onto more things than are relevant, I guess is the closest way that I can put it, where there is a strangeness in the property of numbers, which is that you will solve an equation sometimes. I remember this from physics. You solve a quadratic equation and you get an output, one of which is applicable to the system, the other one of which is not applicable to the system. Like you end up with negative time or something. And your negative time isn't relevant, and so you discard it, and so your solution is the positive time. And is that not just a feature of all mathematics, that when you perform the act of codifying nature into something that is a solid quantitative relationships, that some solutions to your equations don't have any bearing on anything? Because it sounds like what they're doing is that they're starting with...
I think he's saying that they don't have any bearing necessarily on our regular everyday lives, but that there could be a relational system that's outside of our everyday lives that persists. Something like that, if I'm trying.
Precisely. That was going to be my precise response. Is that, yes, in our particular fairly trivial space-time world, many of these solutions are probably not relevant to us, and that's just another indication of how cheap and low budget our headset is. But the mathematics is telling us that there's a richer world out there, and it's a richer world of potential experiences that we're being denied. To think about it this way, try to think of a color that you've never seen before. Try to think of a specific color. Imagine a specific color you've never seen before. Right? Nothing happens. We only have 3 color receptors. Pigeons have 4. Pigeons are presumably living in a world of color experience on an everyday basis that you and I can't even imagine.
Or bugs
And
seeing the
sure
UV.
must have.
Have you seen those videos where there's like bees flying around and you see the flowers in UV or something like that? It's stunning
That's
how
right.
different the world looks. Infrared,
Completely.
radio waves, all these. There's technically so much color that we can't see.
Absolutely. So the fact that there's all this mathematics that seems irrelevant to us is a tip that, wow, our headset is really the dumbed down, cheap version. And all the mathematics is hinting that there are realms of experience that are beyond anything that we're letting you experience right now. So we're in a cave.
What is we talk about the structure of the amplituhedron, but if we're outside of space-time, this is a purely mathematical structure? Is there something that is not energy and mass that is at play here, or how does it work?
That's a great question. All they can say is these are these geometric objects right now, right? And these geometric objects, in their structure, they encode for these properties like unitarity and locality. And the volumes code for things like the scattering amplitudes. And they make the math a lot easier, by the way. When you do like 2 gluons in and 4 gluons out computations inside spacetime using quantum field theory, hundreds of pages of algebra, millions of terms required for just one interaction. The new structure outside spacetime, for the same interaction, 3 or 4 terms you could write down by hand. Mathematics goes from hundreds of pages to a single page you can just scratch down 3 or 4 terms. And you also see new symmetries that you can't see inside spacetime. So all of a sudden, we're getting a hint that we're being rewarded here. This is an incredible hint that you're onto something. The math is becoming simpler. You're seeing new symmetries that are true, but you couldn't see inside your headset. But what's interesting with your question here is, so what does this mean? What is this stuff outside of space-time? What kind of world is this? For one question that you would ask naturally is, okay, physics is about dynamical systems, right? It's about things that are moving and changing and so forth. So what kind of dynamical systems and what kind of dynamical entities outside of space-time should we be thinking about here? Now, right now they have none, right? These are just geometric structures or data structures like combinatorial structures like decorated permutations. So we're getting these combinatorial structures and we're getting these geometric structures and relationships between the combinatorial structures and the geometric structures. But no one that I've seen so far, and I'd love to be shown wrong, I'd love to see any new work on this, but no one I've seen so far in the physics is proposing new dynamical systems that give rise to the amplituhedron and these decorated permutations, right? That and no surprise, I mean, these things are brand new. This is less than 10 years, right? So there's no surprise. So that then raises the question, what kind of dynamical entities exist beyond spacetime? What do we mean by dynamical entities, dynamical units outside of spacetime? What could we possibly mean? We don't mean physical particles. Physical particles are entities inside spacetime. These are entities outside spacetime. So either we're going to deny that there are such entities, or we're going to have to posit that there are entities outside of spacetime that engage in dynamics. And
that might be one of the oldest proposals in the entire history books, though, in some sense, right?
Yeah,
I feel like all ancient peoples, to a certain extent, have posited the existence of entities outside of space-time. I mean, they wouldn't have used the same language, obviously, but there's always been this sense from the earliest moments of humanity that there's something beyond this realm. And so I think that, in some sense, that intuition is interesting with respect to the idea that people are finding at least being able to extrapolate their empirical observations and find ways to arrive at those that involve experiences that are beyond those that are actually happening in the world. It's a very intriguing idea.
It is
Well,
really intriguing, and it's
great.
also really old, like you said. Like if I'm listening to this, and I immediately jump to a sort of Pythagorean mysticism, where there's these numbers and they relate to each other in a specific geometric way, and there's a belief in the tremulous significance of this relationship, because why would you be able to arrange some numbers in a triangular shape if that wasn't significant? And I feel like we've been stuck with that for thousands and thousands of years.
That's right. And I would say that there have been, throughout human history, there's been the mystical tradition that says that space-time isn't the fundamental nature of reality. They probably wouldn't have used the metaphor of a headset because they didn't have that. But Plato used the metaphor of a cave, right? So Plato's cave is very, very similar kind of thing. They used the metaphors that they had. I'm sure if Plato were here today, he'd probably say, "Oh yeah, I like the headset better than the cave. I mean, I only use cave because that's all I could do, but headset's much, much better." So yeah, I think many mystical traditions have said that that there's some kind of consciousness. We have to put scare quotes around it right now. As a scientist, it's just a word, but there's some kind of notion of consciousness, maybe a dynamics of consciousness outside of space-time. Now, the state of play, though, in human thought has been that those mystical traditions, of course, have been very helpful on a personal level, and people meditate and they get peace and so forth. But there's been two strands in human progress. There's been the physicalist, rigorous mathematical science, which gives us all the technology that we have today, but maybe doesn't give us peace. And then there is this mystical tradition, which gives us maybe personal insights about consciousness, but hasn't given us a shred of technology. And so it's easy for the two camps to look at each other disparagingly and say, well, mystical schmystical, or your scientific
Disaster, like techno catastrophe viewpoint.
That's right. But here we see now the possibility for the two to begin to dovetail. What if it is true that the dynamical entities beyond space-time can be properly modeled, rigorously modeled as conscious entities in a dynamical system, a social network? And what if we could use that mathematical theory of consciousness that's absolutely rigorous to actually show that it gives rise to structures like the amplituhedron, which then give rise to particle processes or describe particle processes inside space-time? Then all of a sudden, this rift between science and spirituality that's been for hundreds of years, because science has only been around really, we can argue, but I would say since Galileo. That would be where I say science. You might argue the Greeks had some early version of it, but I'll go with Galileo.
Whatever they had, they forgot about it for 1,000 years. So.
Yeah. So I mean, I'll put it this way: the Greeks did some good stuff, but we lost it, and we had to reboot. And so here we have the chance now to actually have a rapprochement and actual mutual learning between science and spirituality. If it turns out that, and now I'm going way beyond what the physicists are saying here, right? So what I'm saying now is I'm not pinning any of this on physicists, like these high energy theoretical physicists. They might look at me and go, this is nonsense. I mean, we have amplituhedron, we have decorated permutations, and we don't have consciousness. That's consciousness. So I'm
well, we kind of led you into this too. I mean, I think that it's actually, I mean, the congruence between those traditions is hard to not notice, I guess. And like, I'm sure you would have gotten a room with a view at the Vatican had you lived 500 years ago, right? It is really magnificent if you're able to unify the spiritual with the scientific, because I think there is a good argument to be made that in spite of the oppressive nature of religion and so forth, that people don't have much of a commonality in their spiritual approach to life in a country like ours. I can't really speak for other countries too well, but it's very fragmented. People very much look to science like it's gonna guide them, but science isn't always equipped to do those kinds of things. It doesn't do well with the should, right? It just tells you how things work, perhaps, but not how they should go or how the best way to live is, something like that.
Well,
And
science is so devoid of spirit. Scientists are allergic to the very idea that you would speak of there being a consciousness that permeates all the way through. Like we were speaking to somebody the other day who studies desire, and he was like, the oak tree doesn't have any desire. And it was taken as an immediate given foundation for the precepts that were built on top of it. And I've always thought that that's a somewhat short-sighted construction, that the complexity of life and of will and of all of these conscious movements begins at the human brain, basically. And that seems to always be the problem, because you look at the human brain and you're like, well, how does it happen that we have all these experiences and where do they come from? And it's like, well, for me, I place the foundation much farther back, where I'm like, well, we have to understand life and the origin of life, and then we can start to trace back what is consciousness and everything else. But it seems like you go even farther to the more fundamental, where you're like, no. We have to understand what is outside of all of this, what gives rise to all of it, and then we can resolve this notion of, mind-body duality. Or
can I also add that I know somebody's typing a comment right now, like, you guys need to change the name of your show to Mystifying Science. Like that's what always happens when we stray into this territory. But I want to just push back on that too, because I think that ignoring the mystical traditions is a really stupid thing to do too, because it's been so important for thousands and thousands of years. And I think that it's a little bit arrogant to treat our ancestors as if they're just superstitious cavemen, right? I think people, in some sense, did know how to live. They at least got us here today, right? They built this civilization that I'm privileged to experience. And so there probably is a lot of truth in the stories that they were telling. And so in some sense, the better we can do to understand that and to unify it with our scientific understanding of the world is really, in some sense, demystifying the entire experience. We're really understanding things better. And that's our job, really, as thinkers or scientists, is to understand the universe, to get to know this place better.
Yeah, I completely agree. And I think that the mystical traditions had some very good ideas. They probably had some nonsense. Just like in science, we have great theories, and then, of course, most of the theories we come up with are nonsense. That's just the way it goes. But ultimately, I think there's going to be a synergy between the two. Now, what's going on right now is that it turns out that space-time falls apart at 10 to the minus 33 centimeters. So the foundation of most physicalist science, the reductionist physicalist science, that says as you go to smaller and smaller regions of space, you get more and more fundamental elements of reality and more fundamental laws that describe those fundamental elements. That's the reductionist, what you might call the micro-reductionist approach to science. Well, we have a clear understanding that falls apart at 10 to the minus 33 centimeters, probably well before. So that reductionism is not going to be the final answer, because space-time itself is not the final answer. And it's been the success of space-time, the incredible success of space-time as a framework for science for the last several centuries, that has led many scientists to say we don't need the spiritual stuff. Look at all the stuff that we're doing with this space-time assumption. Well, but now the glory of science is that it comes along and says, wow, that assumption really worked for me for several centuries, but that assumption is false. That assumption is not, it's not fundamental. Space-time has to emerge from something deeper. What? Science can't tell you. I mean, you have to go out there and look and make your own theories about what's deeper than space-time. And so when we go out there and look for something that's deeper than space-time, why not look at consciousness? What else are you going to look for? We're looking for dynamical entities outside of space-time. I'm happy to have anybody propose whatever dynamical entities outside of space-time they want. I'm proposing consciousness. But if you have some others, that's perfectly fine. You might say, I just want some kind of automata. And I think there are some approaches that are like that. Maybe Stephen Wolfram's kind of approach might be more like that. So you might still deny that there's consciousness outside. So, but I see that the next thing that's going to happen here is we'll have to get this mathematics of dynamics outside of space-time. And then as scientists trying to understand consciousness, and many of my good friends and colleagues are doing that, right? That's a big thing in cognitive neuroscience and artificial intelligence, is try to get theories of consciousness. Most of them, I would say most of my friends and colleagues who are doing this, 99% of the theories are physicalist or functionalist, that they basically assume the old space-time framework, that space-time is fundamental, and that there's certain functional properties of objects or systems inside space-time. If you have the right complexity or the right causal structure, then consciousness emerges. So the big picture is, of course, space-time is not conscious. And of course, consciousness is a latecomer in the universe. But if you get the right kind of complexity in physical systems, then you get consciousness emerging somehow. And that whole, well, the first thing is to ask, so how successful have they been? Right? My colleagues are brilliant. And I mean that honestly. I'm really good friends with many of the key players here, and colleagues with the rest, and they're brilliant. So it's a fair question. These are it's not like we're dealing with stupid people. These are really, really smart people. They've been working on this for several decades. They're trying to start with physical systems or functional properties of physical systems, like integrated information or orchestrated collapse of quantum states of neuronal microtubules, or workspace architectures, global workspace architecture, whatever it might be. There's a lot of them. Attentional schema theories, there's higher order theories, there's first order theories. There's lots of theories. And brilliant, dedicated researchers doing this work. Absolutely right. But the question I always ask them, and I always will ask them, is, okay, great. So what specific conscious experience can your theory explain? What is the orchestrated collapse of quantum states of neuronal microtubules that must be the taste of chocolate and couldn't be the smell of garlic? Or what is the integrated information pattern, what they call the Q shape in their theory, that must be the experience of, say, visual space and couldn't be the experience of auditory space or haptic space? What? So can you give me one specific conscious experience that you can explain? And the fact is, there's not a single success story, not one. So there's lots of theories, decades of work, hundreds of researchers, thousands of experiments, lots of theories on the table. How many specific conscious experiences can be explained? Zero. And I think that's it. I know it's not because the researchers are dumb. They're brilliant, and many of them are just flat out geniuses. It's because you cannot start with space-time and matter inside space-time and boot up consciousness. It's not logically possible to do that. Just can't do it. So the failure is principled, and that's what science is. We will learn that. The way that science is going to learn that is by having hundreds of geniuses work for many decades trying to do what's impossible, to boot up consciousness from space-time. And when they really, we have to rub our noses in it. When we really understand, you cannot boot up consciousness from physical systems inside space-time that are not conscious. It just can't be done. Then when we can do the opposite, when we can start with the dynamics of consciousness outside space-time and show that we can get all the physics inside space-time from that, then we'll have the switch. The switch will happen in which now consciousness will be taken quite seriously. We'll view space-time as what it is, just a trivial headset. All of science so far has only been studying not objective reality, just our headset. We thought we were studying the true world. No, we were just examining our headset. We didn't know that it was just our headset. Just in the last 10 or 20 years, we've started to take off our headset and go, oh, wow, we can actually do science outside the headset. And what I'm proposing is, okay, now science is taking its first baby steps outside of the headset. What are we going to find? Well, we're finding right now these, amplituhedra and decorated permutations. But what we're really going to find is there's this network of conscious agents ready to greet us, and we need to study consciousness in its full, social interaction complexity. Then we're going to see this interaction between the ideas of the spiritual traditions that have been there for thousands of years, but didn't have any rigorous statement, right? There was no rigorous statement. And now we have the rigor of science, which was hard-earned, very, very hard-earned. We've learned our lessons studying our headset, mathematically precise theories, no hand waves, rigorous empirical tests, no BS. If you can't get the data, come back and tell me when you got the data. If you don't have a mathematically precise theory, don't waste my time. We've learned how to do it correctly. So we need to apply the same thing to the spiritual concepts. And I think we can. In spiritual traditions, they'll say that the words that they use are just pointers, right? So don't take them literally. The Tao Te Ching says if the Tao that can be spoken of is not the true Tao, right? And once you understand that, then you can go ahead and read the rest of the Tao Te Ching because you understand the right spirit in which to read it, which is not as dogma to be taken literally, but as pointers for your own spiritual advance and for you to do your own exploration based on those pointers. So it's not about now we have the right story and you other spiritual seekers are wrong. It's not about that kind of thing. It's about pointers. But the problem has been that the followers don't listen to the masters, and they get addicted to the particular statement, of their religion. Instead of using it as a pointer to something deeper, as if you don't say it my way, then you're wrong, right? You have to say it this way. It has to be this format, and so then we get this fighting. So what's going to happen is that we're going to get new pointers when science and spirituality interact. We're going to get new pointers that have this science flavor where the pointer itself tells you its limits, right? So Einstein's theory of spacetime is so precise that it tells you its limits. It tells you this is a wonderful theory until you get to 10 to the minus 33 centimeters. Then you got to throw me away. My pointer falls apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. Hooray! That's what we want. Pointers that tell you what's going to be true about any pointer, its limits. So we don't want pointers that you can sort of believe that we've found the final truth. No pointer is the final truth, ever. There's no scientific theory of everything. There can never be a scientific theory of everything. Reality transcends any potential scientific theory infinitely, not just a little bit, infinitely. And I'm speaking that, as a scientist, it's science will forever only scratch the surface of reality, forever. We will only, and yet, science, what science does is it gives us rigorous, clean pointers to certain perspectives on reality. The most precise pointers that we can have on perspectives of reality. And that's what but the reality is not a physical reality, we're realizing it's a spiritual reality. So all of a sudden now our scientific pointers will be pointers to projections of a spiritual reality. And that's what I'm looking forward to seeing happen. It will take decades because I think my cohort that's still working on consciousness will probably continue for a few more decades, really trying to boot up consciousness from space-time and particle dynamics inside space-time or physical system. I think it'll probably take a few more decades of failure, patent failure, that before we really realize, okay, that game is really over. We really have to bite the bullet. The physicalist reductionist paradigm, which was so successful for centuries, has reached its limit, and we actually have to recognize that wasn't the truth. It was just a headset. It was just a headset that was dumbing down a much deeper reality, which is this social network of conscious agents. Or by the way, that's just my language, and my language is again just another pointer, right? So I don't take when everything that I'm saying applies to my own theory. It's not the final word. It itself is just the next step pointer. The reality transcends. The reality of consciousness transcends anything that my little mathematics and Markov chains is saying.
I really appreciate your humility about that. I think this is something I'm really always trying to impress upon students too, is just that science has to be this discipline that's always checking itself and always updating the way that it sees things. And I think that's really the glory of science as a whole. I mean, let me see if this goes with what your ideas were, but I'm curious.
You've been scribbling frantically.
Yeah, well, you know, if there are these, well, all right, so I have two things. I'll actually get back to this one. I'm actually curious of what you're saying about the limit that we've reached and the inability to construct consciousness from physical processes in space-time. Do you think that will be evidenced by the lack of ability to fulfill the promise of artificial general intelligence? Do you think that our inability to engineer consciousness will, in some sense, reinforce the paradigm that you're expressing here? Or do you think that could still happen, but it would be informed from some other dimensional, I'm not going to use the word space, but from some other relational levels of conscious experience that are not accessible in space-time?
That's a great question. I think that the failure that's going to really be the final death knell in this whole approach will be the failure of their own theories. When my colleagues and friends who are doing this research recognize that they can't explain even one specific conscious experience, and they've been working at it for, who knows, maybe it'll take a century. They've been working on this for a century. They're not stupid. They're really brilliant. They're going to realize if it could have been done, we would have done it now. And we can't explain even one specific conscious experience. And all you need is someone like me in the audience to raise my hand and say, okay, well, great theory. So what specific conscious experience can you explain? And it's a real downer when you say,
when you say explain, do you mean like provide a mathematically rigorous prediction of all the aspects of that experience from some given stimuli, something like that?
So I'll be very specific. So integrated information theory says that specific causal structures, different Q shapes, must correspond to specific conscious experiences. And so my question is, in their language, what specific Q shape must be the taste of vanilla for principled reasons? And what are those principled reasons? And why is it that Q shape could not be the smell of chocolate or the feeling of headache?
Do you know Stephen Grossberg's adaptive resonance theory of consciousness?
Yeah, a bit, yeah.
So, I mean, for him, I think that the explanation would be that corresponds to chocolate and not to garlic because of the ways that our perceptual systems sum to create cohesive resonance in the brain. And so there's all of these different sensory systems that are able to look at the chocolate and everything from color, shape, texture, smell, the way that it reflects the light, the history of how it arrived to this location, the package that it came in, it all sums to create the experience of the chocolate, because the chocolate does not exist in isolation in a black room where it suddenly appears to you and it's something that you haven't seen before. It's a context-dependent relational emergence on the back of the way that our sensory systems work.
Right. So in a case like that with Stephen Grossberg, who's a brilliant theorist, I mean, the question that I would ask is, what specific resonance pattern or system must be the taste of chocolate for principled reasons and could not be the smell of garlic?
He's got it all.
I mean, I don't think that he has that specific one or any.
I think that he might. Like he claims that he does.
Really?
And yeah, he claims that he does. We should. You know what? We should just have you talk to him directly. We'll put a pin in this.
Sure. Yeah, we could just say, okay, we're interested in give us a conscious experience like vanilla, and give us the adaptive resonance pattern that must be that, and tell us why. Why is that conscious experience uniquely identified with that adaptive resonance pattern? Why is it in principle that way? And why is it that if that resonance occurs, that conscious experience must occur? And vanilla must happen in that case. I would love to see that.
I mean, that seems like a pretty easy one compared to something like, why does the hair on my neck stand up when I see an incredible musician performing, or something like that, right? Like we get into these territory, or when I walk into a cathedral, or when I walk into the Grand Canyon, or there's a lot of experiences that seem like they'd be even more difficult than just some obvious stimuli that has resonance.
The numinosity of experience, I think, is what it is, right? It's this massive sense of history and effort and time and beauty and all of these different things that sum together to create this experience that cannot be defined as anything except for spiritual.
Transcendent.
Yeah, like I hike through the
Like,
Grand
even that
Canyon.
word transcendent, what is that? Where do we get that?
Oh, I mean, for me, it's like I take people on these hikes through the Grand Canyon. So as a backpacking guide, it's rim to rim
Cool.
to rim, and so it's for charity. They're raising money, and so they're doing these extraordinary feats of strength. And there's something about walking through the Grand Canyon that puts you in a position of crossing all of these bands of time and all of these biomes as you move between it, and you see all this evidence of human habitation, of the massive arc of the peopling of the Americas, colonialism, the arrival of the Westerners, the destruction of the habitats, the establishment of the United States as a federal power, the rise of the national park system, and you walk through all of it, and it's just around every corner is something that just blows your mind about it. And I think that's what transcendence is the physical body is in one location, but the mind moves through the arc of history,
All times
and
at once, almost.
yeah, you're just layered onto all of these different times and places at once, and you're disappearing. You're
Well,
you're
that was
proving
quite a magic
point.
trick, yeah.
Yeah, my camera seems to have lost focus. Does it seem unfocused now?
Yeah, you could turn it off just for a second. Basically just inside of Zoom, turn your camera off, see what
I think
happens.
it'll refocus.
Maybe.
Let's see. Where do you go to turn it off?
Down at the bottom left, there should be a little camera icon.
Stop
just-
video?
Do that. And then come back.
Okay.
Oh. Is it?
A little bit better, yeah.
Yeah, I think it's good.
yeah.
Okay.
Okay,
can-
yeah, sorry about that. Yeah.
That's totally fine. We can deal with that.
Yeah. No, I agree with what you both were saying. I think the way to deal with my colleagues in the sciences on this would be to say, I take the simplest conscious experience that you want. Whatever you think is the most simple conscious experience. I don't need something exotic or transcendent, just the simplest conscious experience, and give me the integrated information theory or the global workspace architecture stage or whatever that must be that conscious experience. And my prediction, I would bet long odds, that is just in principle not possible to do. So they'll never be able to do it. And the nice thing about science is that eventually that fact will become clear, and that whole approach will be doomed, and people will move on. I think then the history books will look back and ask, why did it take us so long? Why did, I mean, these are not dumb people. They're brilliant researchers, geniuses in many cases. Why did it take so long? And I think it's because we had physicalism and space-time being fundamental as such a grip on our imagination that it was just very hard for us to break out of it. Just like it was very hard to get rid of flat Earth. We just believed it so deeply.
To a surprising degree, actually.
Right. Yeah.
It's empirically consistent, it's empirically consistent in some sense, right? Those models are very tight, all the epicycles, and it works out,
That's exactly. That would be the geocentric. The epicycles are about the geocentric picture of the universe and so forth. So yeah, you can make it work out, but here they can't even make it work out. You can't even. There are no epicycles that the cognitive neuroscience can use to get to these conscious experiences. So we can't. There are no hand waves, and I think a lot of my colleagues are uncomfortable being on stage with me because they know when it gets to the point, I'm going to ask this question. And they're going to have to give the same answer they gave years ago when I asked them on the stage the same question before, which is, no, I can't give you a single one. And for me,
oh, go ahead.
It is sad. For me, it's sad because they're brilliant. If the only reason they're not making progress is that they're strapped to the wrong assumptions. If they could break free of those assumptions, this could just take off. So, but as long as you're believing in flat Earth, I would not trust you to build a space program. You can't build a space program on a flat Earth. So, and you can't build up a theory of consciousness from physicalism. Just can't do it.
Okay,
Doesn't matter how smart you are.
Might be able to get to space, but you're going to be mighty confused once you get there.
It's probably true. You can't get somewhere. Okay.
I mean, but by the way, but we didn't AI.
No, go
that's
ahead.
all. Yeah,
AI.
We didn't actually touch on that.
Okay,
Yeah, 'cause
okay.
I did ask
okay,
about that.
okay,
I want to
okay.
make sure we don't
Because
forget
I
about
have
it.
a question that's been hanging, but I can get to it after AI. Go ahead.
I asked you this earlier, but I want to make sure. It seems like that if we don't have the proper understanding for booting up consciousness, is that going to get in the way of us actually making artificial consciousness too? Do you spend any time thinking about AI?
Okay, so that's a great question because it raises a whole other important issue, and that is the way that people typically think about consciousness in space-time is that consciousness is a feature of certain objects inside space-time, like human beings, and not of other objects like rocks, right? And what's the difference? Well, a rock lacks the certain kind of right complexity that the human brain does have. And so our assumption is that somehow consciousness is tied to objects in virtue of having the right kind of complexity in those objects, in their dynamical properties. And I'm saying that entire approach is wrong from the get-go. There's nothing to be saved from that kind of point of view. Nothing. Space-time is just a headset. So it's just an interface. So right now I have an interface. It's a desktop screen, and I'm interacting with you. And so I see certain pixels on my screen that are for the face of Michael Shiloh and Anastasia, and then other pixels for a curtain, or your desk. Now, I could say, well, yeah, so that means that some pixels are conscious, right? The pixels on Anastasia's face, those are the conscious pixels, and the ones on the desk, those are unconscious. Well, that's dumb. That's really stupid. The pixels are just pixels. They're just a portal. And some of the pixels are a portal to, what Michael Shiloh was thinking right now, or they're not a perfect portal, but they're a fallible but genuine portal into your conscious experiences. Whereas the pixels corresponding to the desk are giving me no such insight. But pixels are just pixels. You to say these are the kind of these pixels have this kind of complicated dynamics, and that and therefore they're conscious. Well, that's dumb. Pixels are just pixels. Space-time is just a headset. Period. It's just a user interface. So the distinction that we make between living and non-living physical systems is not principled. It's a mistake. And the distinction we make between conscious and unconscious physical systems is not principled. It's a mistake. We are always, in any time we're interacting with anything, we're interacting with consciousness. If I see a rock, I'm not saying that the rock is conscious, but I'm also not saying that your body is conscious. Neither is conscious. Your body is just a symbol on my interface. You are not your body. In fact, my body only exists when I perceive it. I have no neurons right now. If I looked inside my skull, I would see neurons, but there are no neurons. When I'm not perceiving my body, I don't have one. A body is an interface symbol. That's all it is. So this is hard for a lot of people to absorb, but this is with the implication of space-time being doomed, and it's just a user interface. The distinction between living and non-living is not principled. The distinction between conscious and unconscious is not principled. But I'm not saying that rocks are conscious and so forth. But I'm also denying that human bodies are conscious. These are just the human body is just a symbol. It's just an interface symbol. It's not local realism is false. Your body doesn't even have a position when it's not observed. It doesn't exist.
Hey folks, first Demystify Sci live event is happening this year in Austin, Texas on April 7th and 8th. Please come out, hang out, meet us, meet other curious investigator audience members. You can also hang out with our invited speakers that are going to be there, including Pierre-Marie Robitaille, who's going to be speaking about the liquid metal sun and ushering us through the eclipse. Also a number of different speakers from the University of Texas, Austin. It's going to be freaking incredible. I want to see you there. So grab your ticket and I'll see you there.
You said something really interesting about how the only way that we know to open portals onto consciousness is through reproduction. It's by having kids, which means that I think you would agree that all life forms are the process of opening portals of varying configuration.
Right.
So then, don't we end up at an obligation to understand the origin of life in order to understand what it actually means to open a portal in the first place?
Well, in this framework, see, the origin of life assumes the standard physicalist space-time picture, right? In which there was the Big Bang, there were particles, there was no life, and eventually life evolved, and there's somehow the physical origin of life.
So
And I'm
okay,
saying,
let me parameterize it a little bit, because I think
okay,
that
sure.
life precedes cells, and cells are the simplest form of life that we know how to recognize. The same way that the forces that drive a hurricane to form precede the hurricane, but the hurricane is the thing that we identify as being the subsequent effect. And so life precedes that, but before life takes a corporeal form, because I assume that cells must arise. And so if cells must arise, therefore there must be a moment where it becomes a corporeal portal rather than a theoretical.
That's right. So what we'll have to do is to have a dynamical system of, say, conscious agents outside of space-time, projection into space-time that gives us to what we call cells in the space-time. Then we'll have to say, okay, when a cell, for example, just replicates, maybe it's not sexual reproduction, maybe it's asexual reproduction. When it replicates that way, of course, we see certain things in terms of space-time, in terms of DNA, replication and shifting and moving things and so forth. What does that mean in terms of the dynamics of conscious agents beyond space-time? What's really going on? Once we understand what's going on there, then we will be able to, I think, have technologies that will, again, outside of space-time, that will allow us to create what looks like the birth of new life forms inside space-time. But the deeper picture is that not only life, but consciousness is fundamental. So we're never creating life. We're only creating new portals into life. So no new life is being created, only new projections of life.
And so do you equate consciousness and life?
Yeah, I would say that ultimately all life in this deeper sense is conscious life. Right.
And so if the conscious agents, it can be renamed as life agents. So then in this metaphysics, life and consciousness exist outside of space-time.
That's right. Prior to space-time.
Is there a
Because
sense?
space-time is nothing. Space-time is literally nothing but a cheap data structure. That's all it is. It's just a cheap headset.
Do you have a sense of whether the interactions in our dimensional reality reverberate through these higher dimensional realities and vice versa? Like, I think about going one way, maybe like the origin of our ideas, like where does an idea come from or something? And these sort of revelatory experiences. I think most people who have had brilliant ideas would describe them as sort of revelations. They just sort of appear to them in the shower one day, something like that. But then going the other way, are we affecting other worlds that we don't even realize we're affecting? Are we giving other people ideas in other dimensional realities? Is there a two-way street here, or are we somehow isolated from it?
That's a great question, and it brings up something that could be very misleading in my language of all these little conscious agents interacting. It sounds like I'm saying that you and I are just some little conscious agents, and that there's a lot of conscious agents that are separate from us and so forth. That is merely because, using mathematics and doing science, I can't model the ultimate one consciousness. I have to do what I can do, which is to model little consciousnesses, knowing full well that that's not the whole story. Okay, my feeling about the story in terms of natural language, and again, even natural language is just a pointer here, is there is ultimately, one infinite consciousness. And all my little conscious agent networks are just a projection. And because that's what I have to do as a scientist, I can't deal with the whole thing. So I have to deal with little projections where I can do my little mathematics and make progress. But in this framework, I am the one infinite consciousness talking to myself in an avatar called Michael Shiloh, an avatar called Anastasia, and an avatar called Don. But I am the one consciousness. And so in some sense, the answer to your question, Michael Shiloh, is that not only are there effects, but they're immediate because you and I are the infinite consciousness. All these other conscious agents are merely the one consciousness taking on different projections. Even now,
You're sounding like a poet now, Don. You really you're sounding like a classic poet at this point. It's these are things I've read. Really though, I mean, it's really it sounds like Yeats or something really old to me. It sounds in some sense like the rediscovery of an ancient wisdom. It's hard to not see that. I didn't mean to interrupt you. I just I couldn't help it.
Well, and I agree. It's like the perennial philosophy in some sense. But in this case, I didn't come at it because I was trying to like mathematize the perennial philosophy. I was brought to it sort of kicking and screaming because that's just what the science sort of demanded. I'm trying to understand consciousness. The physicalist approach, it became clear to me it won't work, and I don't want to waste my time. I simply don't want to waste decades of my time doing what is in principle not possible, and I want to persuade my brilliant colleagues that their time could be better spent than that. And so, but when you come to a theory of consciousness, it is my own mathematics that made me realize that what I'm doing is trivial compared to what needs to be done, and that it's in principle trivial. It's not merely because I'm not smart enough. It's because in principle I could not write down the theory of the one consciousness. To do that, I would have to. There's something called Cantor's hierarchy of infinities. So there's not just one kind of infinity. I mean, we think of infinity as something very, very big, but there are infinitely many infinities, and each successive one is infinitely bigger than the one before. So there's an infinite hierarchy of infinities, and to get to a scientific theory of the one, I'd have to go through this entire what's called Cantor's hierarchy of infinities mathematically to get my model of the one, but there is no end to the hierarchy, so I can never get there. So as a scientist, I'm forced to use these little models of little conscious agents and so forth. I can look at how the conscious agents are interacting and how they're related. We're going to publish a paper where we actually have what's called a partial order on all these consciousnesses. So we can actually have a logic. It's a non-Boolean logic of consciousnesses. And this logic gives me a lower bound on the complexity of the one. So it doesn't tell me how complicated the one is, but it tells me the one is no less complicated than this nasty thing. And so I can look at this really nasty non-Boolean logic and say, okay, whatever the one is, it's much more complicated than this, and this is pretty nasty. So that's what we can do. But what we can't do is say, here's my mathematical model of the one, and then I'll show you how all the projections come down. We'll never do that. So that's why I said science will only forever barely scratch the surface of an infinite reality. So essentially we'll get measure zero. But from this framework, there is another way to know that infinity. And that is without concepts. You are that infinity. I am that infinity. And when I let go of all scientific concepts or any spiritual concepts, any concepts, and just be present with myself, I am in the presence of that infinite intelligence. And that's where I think all the good ideas for the science that we do comes from. So when going into that silence is where you get the good ideas, and then you come back in but as long as you're not taken in. I mean, I do science, I enjoy science, but it's easy to be taken in and go, oh, I've got the theory of everything. No, you don't. You don't have even the theory of the surface. You barely scratch. But it's much better than what we've been doing before, because before our pointers were not precise enough. And it was easy for us to be dogmatic, to say, my way of saying it is the right way of saying it, and your way is the wrong way. And if you don't take my way, I'm going to kill you. That whole dogmatic thing comes from having bad pointers and believing are bad pointers. So that's where science is going to help, is to give us these pointers that tell us this pointer stops here. So don't take me seriously as the truth. I'm not the truth, but I'm a better pointer than that pointer. So this is a better pointer than that one. And so we can do that, but we'll always know that. But if you want to know the truth, then let go of all pointers and look inside.
Yeah, that's one of the beautiful things about mathematics, for, love it or hate it. But the nice thing is you can lay it out on the table and everybody can look at it and see. Like, one thing I loved when I was like back in, I don't know, coming up through school, I loved that there was always a right answer for math problems. That was always just somehow very existentially reassuring. But in terms of like these infinities and the vast scale of these agents, let's say the summing of the one and all of this, how do you avoid the sense of smallness in this sea? Like, how do you avoid the sense that your own individual experience, one's own individual experience, doesn't really matter much?
Futility.
It's futile, or your actions in this, very, I don't want to say trivial plane of existence, but this
abridged realm.
There you go. Abridged. I like that. This dumbed down version. Like, how do we avoid feeling like those consequences aren't important, and so actually develop some productive sense of responsibility towards our own future and our families and the people around us? I just feel like somebody who's looking at this work without fully understanding it might say that you're letting people off the hook for, behaving badly because it just doesn't matter. It's a trivial level of existence, something like that. And I know you don't feel that way, but I was hoping maybe you could respond to it.
No, that's a great question, and I'll first push on the uselessness aspect of it before I talk about the other. And that is, I mean, it's certainly true that everything that we build here is going to be destroyed, right? Everything. Your beautiful house will one day be ashes. Your kids will one day be dead. You yourself will one day. Everything that. So if you're looking for your meaning in anything that you can build or see, you will be disappointed, and you will realize the futility of that at some point. So anything inside space-time is doomed. So when we say space-time is doomed, but that means that all the stuff that we build inside space-time is doomed. But from this point of, if you think that space-time is the final reality, then of course that's a very, very nihilistic pronouncement that I just made. Very, very nihilistic. I mean, it's just, space-time is all there is and it's doomed. Well, then what's the point? But what I'm saying is, yeah, space-time is doomed. Everything inside space-time is doomed. But hey, space-time is just a headset. So think about it. You're playing a virtual reality game, but for some reason you took a drug and you don't realize it's just a game. You're taking it quite seriously. And the guys that are coming after and shooting at your avatar, you think they're shooting at you, and that you really have skin in the game. So when you, in that case, then yeah, you're going to get really scared and get all worked up and so forth. But if you're in the game and you know that that's just your avatar, it's not you, and you're a consciousness that's utterly outside this game, then it's a different kind of thing. And then you can build houses in this world, whatever, or do whatever you want to in the virtual reality world, knowing full well that it's just a game. So why then play the game at all? And why are we doing this game? The right answer is I don't know, but I can speculate.
Have you read Ender's Game by any chance?
No, Ender's Game? No.
Ender's Game. It's a fantastic sci-fi book, I think from like the 80s or 90s. But it's interesting because the main character at some point is playing this game, and he doesn't realize it, but he's actually deciding moves for like the Galactic Empire. Like, he's this genius.
I think you just spoiled the
did I just spoil it? I'm sorry. I
think we're out of the statute of limitations.
I just ruined
on
it.
that.
Yeah, it's a very old book. I'm sorry, but it's so important, like in this discussion, because I feel like the consequences for our actions, like at least the way I'm reading this, it seems like consequences could reverberate into other realms that we're not even aware of, right? It's like,
yes.
We can't say that certainly, but it seems like at least the door is open to that being a possibility. So even if, you might take off your headset and realize that not only have you been doing something that seemed kind of mundane to you on Earth, but it was in some sense reverberating throughout the whole cosmic consciousness in some sort of very meaningful fashion that you just can't possibly apprehend given your, hardware, something like that.
Oh, it seems like
I
it
agree.
must come with an obligation to the rest of the universe, right?
That's kind of what I'm pushing towards, yeah.
Where it's
Well, at
like
least
you
the
wear
at least the possibility of that.
Yeah, like you wear the headset and you're like, look, I recognize that it's a headset, but it's also the most consequential possible experience that I can have. And I have an obligation to do something inside of the headset that is going to do good or be pointed towards something worthwhile, because perhaps it is all ashes, but if it does, like Shiloh is saying, like you've been saying, reverberate back to something else, then some spiritual, I don't want to say accomplishment because that seems so ego-centered, but some spiritual fulfillment is larger than the physical world and the arbitrary headset.
I completely agree, and so the question is, what kind of story could we tell about that spiritual accomplishment, and what could the nature be? And I'll make a suggestion. And again, the words are just pointers, and I'm sure the reality is far deeper. But here's some pointers. If what we really are is pure consciousness, this one infinite consciousness, and that consciousness is not any specific form. It is that which allows different forms to appear and disappear. Right? It's like your TV screen is not a specific movie. It's that which allows any movie to be played and then disappear. So that's what this deep consciousness is. It's this infinite potential, but any particular form is just one of literally infinite possibilities. So what if this one formless consciousness is about knowing itself, wants to know itself? There are some theorems that no system can ever know itself completely. If you're a system and you want to know yourself, you need to build a model of yourself. Right? Well, when you build the model of yourself, now you're no longer the same because you're more complicated. You now have a model. So now to really understand yourself, you need to build another model of yourself with the model, and you can see where that goes. It's an infinite regress. So there's no way that the process of knowing yourself ever ends. And so maybe what the one consciousness does, is it knows itself by saying, let me try on this headset, and let me go in with both feet and get myself completely lost in it and believe in it. Let me become a space-time physicalist and believe full well that that's the final nature of reality, and be willing to fight to the death over that and so forth. And let me then slowly wake up, slowly and painfully wake up. So I really took that headset seriously. I explored it seriously. I took it very, very seriously. And eventually I realized I transcend that. And what the one is doing is knowing what it is by knowing very clearly what it is not. One headset at a time. And so so this whole thing then of my colleagues spending their time with physicalist theories of consciousness would then be explained as, this is what the one has chosen to do. It really wants to take this headset very, very seriously. It wants to be a physicalist and go after it, and then completely prove to itself, I am not that. And in that, then it wakes up. It no longer needs that headset. It now has a new perspective. What I am goes deeper than that headset. And so it's this one headset at a time. But yeah, it's the one consciousness is always finding out what it is by finding out what it's not, through not just a space-time headset, but literally an uncountable infinity of headsets that is going through.
Do people panic when you start talking about this?
How so?
In like scientific contexts, when you're talking to people that are working
I
on the
don't
hard
think people
problem
panic because they're sure that I couldn't possibly be right. So there's nothing to worry about.
I'm struck by like how it really, we hear a similar story in really old mythological traditions, right? I mean, the most obvious one is maybe Genesis, and this idea that God made man in an image. So you get this sense that it's already this incomplete, but it's sort of like a facsimile, not a facsimile, but like
an
a
iteration.
model, an iteration. Yeah, it's an iteration. It's not quite God, but it's like, some attempt, some stab in the dark at that.
And reincarnation too, right? The idea that you would come back and you would try on an infinite number of headsets and just
Perfect. Yeah.
continuously go through it leads me somewhere else, but I don't want to pull it.
Well, I think that it's significant that people, like, what is an intuition, I guess, is a great question. I mean, why did these people who really had no access to science, and these myths probably predate mathematics even. I mean, why do they have these intuitions? Where do ideas come from? Where's this knowledge arriving from? And even in its kind of inchoate form, that's, like you said, fuzzy. There's pointers, but they're not very accurate. But
the intuition that we're made in the image of something.
Yeah, all these stories, they kind of point at the same. By the way, it's not just like one tradition that says this. It's different traditions from the ancient world all around the planet that are seemingly cut off from one another. These are similar revelations that people have over and over again. It seems if it was just one tradition that came up with a story, you might be able to say, oh, well, that's just a silly story that they told to control people or whatever. But if everybody's coming up with the same story, then you got to think, well, maybe this is actually pointing at something more fundamental in terms of the way that humans understand what they are, which is, in some sense, what we're trying to do today.
I would agree, and it suggests that again, when we think about a physicalist framework and we think about a progression of evolution and from less complicated organisms to more complicated organisms and so forth, then it's very natural to ask, where did these guys get these ideas early on and so forth. But if all life in our space-time headset is merely a projection of an infinite intelligence, then it's no surprise that infinite intelligence expressed in that projected form would have access to lots of ideas, that because it is the source of those ideas. Where did science get them? It got them from that same source that the primitives got it, which is the infinite consciousness that they are a projection of. Or as Christians would say, children of God, but I would say projections of God, but children of God, same kind of idea.
What do you make of the evolution of the physical world, though?
That's a really great question, and partly because I have a nice answer. The mathematical model of Markov chains that we have for consciousness has a nice feature that it doesn't have to have an arrow of time. The entropy in the dynamical system can be constant. It doesn't have to change with the dynamics. So there's no arrow of time in some of our Markovian dynamics, but it's a trivial theorem and proof, and we have it in our paper Fusions of Consciousness. We're not the originators of the proof, but we have the proof in our paper. That any projection, you take this Markovian dynamics that has no arrow of time, take any projection that loses information. So you get an image of the dynamics. You get a dynamical system as a projection of this deeper dynamics. The projected dynamics will have an arrow of time as a result of the loss of information in the projection process. So what this means is that our arrow of time, from the Big Bang to who knows what the end is, the Big Crunch or whatever it might be, that arrow of time is not an insight into the deep nature of reality at all. It's entirely an artifact of loss of information in the projection. So there's nothing to be deeply read about an arrow of time, about the nature of reality, nothing at all. It's not a pointer to some deeper reality. It's entirely an artifact of the projection. Now, I love evolution by natural selection. It's a beautiful space-time theory. It's the best theory we have inside space-time for understanding biological evolution. Nothing comes close. But time is the fundamental limited resource in evolution. If you don't get food in time, you die. If you don't mate in time, you don't reproduce, so forth. Time is what this suggests to me is that evolution by natural selection, the entire theory, which is a beautiful theory inside space-time, all of it, every aspect of it, is an artifact of loss of information in the projection. None of it survives. None of it's an insight. So I think there's a deeper realm of conscious agents in which there is no limited resource. There is no arrow of time. There are no organisms competing for limited resources. But whatever's going on outside of space and time, when you project it into a particular perspective, then it looks like there's an arrow of time from the Big Bang to the Big Crunch. It looks like organisms evolving from life then to consciousness, and then competing and so forth for resources. The life forms competing for resources and competing to mate. So, but all of that is not an insight into a deeper nature of reality. Every aspect of it is an artifact of the projection. So that's the long answer to the question.
It's interesting because it kind of corresponds to the sense that I have sometimes of this flattening of time in our lived experience relative to what it must truly be. Because the separation between the first organism on Earth, the first cell on Earth, let's say, and me seems on some level arbitrary, because within me are packed all of the experiences of everybody that came before me for 4 billion years, and all of the atoms as they spewed from some dying star to come together into this entity that walks around and does things and drinks coffee and has ideas. But it does seem to be an arbitrary separation from that moment, because there must be some memory that's still informing it, whether or not it's legible.
I agree, and the nice thing is that with this new mathematics, the computation dynamics, we can go beyond just talking about this. I would like to write down a dynamical system that has no arrow of time. And so it has no beginning and no end, and so it's just. But then take a projection and show that in this projection, it looks like there's an arrow of time. It looks like there was some origin and things evolving. And so I would love to see how, in a concrete mathematical system, how it looks like there's a Big Bang and evolution happening, and then new, more complicated creatures coming out, and then the whole thing falling apart. All as an artifact of projection from a system. So we would actually see the real quote unquote system that has no evolution and no arrow of time, but we see in the projection, we see all of the features of evolution coming out of it. Now that would be truly compelling when we could actually write down the mathematical simulation and show that. That would be so. If I don't get to it, I hope someone hears this and takes the inspiration to go just do it and write that simulation. I'd love to see it.
Yeah, absolutely.
Oh yeah, it seems like that's never been more possible than today. I don't think there's ever been this many people interested in any particular subject, but especially interested in such esoteric questions. It seems like even outside of the academy, there's just the fact that your work is so popular among non-academic people. Like there's so many people just concerning themselves with questions that have really been studied by just a few individuals over the course of most of history. That's really inspiring to me. And I also want to say that, anything that brings our science closer to this understanding of something like this oneness or interconnectedness, I think is going to be vital for at least the physical consequences in this physical realm. In terms of, I look at our global state being ready to start colonizing space and dragging asteroids back to Earth, and you think, man, we're still fighting with each other here on this planet. And anything that gets us closer to understanding that, our enemies are in some sense us, and that, they might need help, right, in order to not be our enemies in some sense. And the more that we can see that we're all just aspects of a greater project, I think that that's going to contribute meaningfully to a better future. Well, let's say the only future that's going to work out for us eventually.
I couldn't agree more. And in Christianity, Jesus says, "Love your neighbor as yourself." Right? That was one of the top two commandments: love God with all your heart, love your neighbor as yourself. When Jesus was asked, "What's the most important thing?" And from this other framework, your neighbor is yourself, just under a different avatar. So the true, I think, foundation for morality is not simply to treat your neighbor as if they were yourself, to love them as if they were yourself, but to recognize that your neighbor is yourself, just under a different avatar. That is you. How you treat your cat, how you treat another person, is how you are treating yourself, period. And it's only ignorance that lets you think otherwise. It's an actual sign of ignorance to not recognize that what you're doing in harming someone else is actually harming yourself. Now, ultimately, why is the one letting itself do that? Right? Because from this point of view, right, the one is choosing to plunge itself into a headset and is choosing to let itself be so ignorant that it attacks other avatars of itself. And ultimately, in some sense, when you're playing a VR game, when you take the headset off, all the wounds and so forth in the game weren't permanent. They were learning experiences. And that's what's, I think, going on here. The pain that we experience is real psychological pain. And it's a pointer to the one to wake up and to learn more about, okay, I'm not separate from that person. I'm not better than that person. I'm not worse than that person. I am that person. So it's really our moral job here is really part of the job of the one understanding who it really is. Oh yeah, I am not superior to that person. It's really the case I'm not inferior to that person. It's really the case that I am that other person. And I don't really need to polish my Vita. I don't really need to try to be impressive. I mean, there's no, I don't need to be better than or feel bad that I'm not as good as somebody else. There's nothing I need to accomplish because I'm already the infinite. Waking up to that. That's what it's all about. So I might spend my entire life trying to prove how important I am with my mansions and my fast cars and my jets and so forth, and I'm better than everybody else that doesn't have them. And yet at the end, all of a sudden I realized how empty that was because I'm on my deathbed now. I'm 95 years old, and I'm not going to have any of those things anymore. And I realized that whoever I am essentially was never that. And I thought that was who I am. That was my identity. I'm superior because I have all these things, or I'm not just superior because I have all this knowledge that no one else has. And then I realized at the end, I'm not that. And that's what we're here to do, is to plunge into all this stuff, get lost in it, and then realize I transcend even that.
Seems like there's like a deeply pragmatic aspect to this too, because from what I understand, from everything I know about conflict negotiation, the first step is understanding where your adversary is coming from. Like really like especially if it's someone you care about, right? Like your spouse or something. You want to have a relationship tomorrow. You better understand why this person's acting the way they're acting. And
right.
You know, anything that puts you in somebody else's shoes, and in this sense, in a very real scientific stance, really understanding that you are part of that person in a very meaningful and real way, I think gets us much closer to getting past these conflicts that could be extremely threatening to us.
But there's also this really fascinating aspect to this, which is the consumer versus producer, the killer versus the killed. You know, there's a difference in the kind of being that a plant is, or a bacteria that's able to produce all of its nutrients from just insulation. It gets light, it's able to produce everything that it needs, and it changes the universe around it, certainly by putting other things out into the environment, but it doesn't necessarily have to go out and kill things in order to consume them to survive. And when you start to think about it that way, then it starts to curve these possibilities around each other in a really weird way, because it's like, okay, so you're in a fight, but sometimes the fight is necessary to be had. Sometimes it's a life or death situation. Sometimes it is things that cannot be tolerated, and so you must object. And part of life seems to be the process of figuring out how to make peace with almost the violence that's inherent with being alive. Because I don't think it's possible to live without violence as a being that must kill to survive.
It's interesting. I feel like a lot of indigenous traditions see it as the plant giving itself, or the animal giving itself to the human.
Yeah.
And so I think you could see that as even in like a self-defense situation, as your enemy giving themselves up to you. I don't know. It's just one way to spin it, anyways.
Yeah.
Yeah, it's. I agree with your comments, and I guess some earlier cultures even were like giving thanks to the animals that they were killing for letting, in some sense, giving us what we need at your own expense, kind of thing. And that does make sense in the framework in which it's the one in all its various forms interacting with itself. But then there's the deeper sense in which all of this is just a projection of a deep and completely coherent unity that has no need of anything. So these are all. So there's the tension in my view here, because these are all projections. All these things where we see nature red in tooth and claw, those are projections of a deeper reality in which there may not be nature in red in tooth and claw, and yet the projections may be necessary for the one to understand its fundamental unity and lack of red and claw essential nature. It looks like I'm red and claw, but I'm actually not. That was just an incorrect perception and a projection.
And yet
There's
it might
also-
teach you, and yet it might teach you something at that other level too. It's like people play video games for a reason, right? That not necessarily because they like shooting people, but it gives them something, right? The game is so important to human achievement, like that ability to try on situations that don't actually threaten their existence, but they're able to somehow engage in those struggles and learn as a result of them. I wonder
I agree.
if that could be playing out. Yeah.
Yeah, many animals in nature, the young play for, little bears, little foxes, all, they're just, the parents are trying to get them fed and so forth, and they couldn't care less. They're just playing, and that seems to be pretty important. But yeah, no, I completely agree.
So yeah, and I guess in that sense, the physical realm would be a giant play, and I don't think that that's unreasonable to look at the world as a play.
I believe that someone once said that all the world's a stage and we are merely players on it.
It's
I think
Shakespeare.
a lot of truth
yeah, I think
there.
it's been around for a while.
Right. This also brings up an issue about judgment, right? Which we tend to, in Christianity, they say, don't judge lest you be judged yourself. Jesus said that in the Sermon on the Mount. But that's really deep, because in some sense, when you judge others, you're judging yourself in this. Yeah. And in some sense, we're not responsible. We've been plunged into this ignorance, and we come in believing that we're separate creatures. We believe a falsehood that we're separate, that we need to fight for our struggle and so forth. And we eventually learn that no, we're actually this infinite consciousness. But part of the process is learning not to judge others, and learning not to judge yourself in the whole process.
Judgment's
so that's another aspect of it.
Judgment's a complex. Yeah, I mean, because in some sense, I do want to judge myself. Like I do want to do better tomorrow than I do today, something like that. But I understand that that exercising that without exercising it upon myself, like exercising it upon other people, would be silly in some sense too. But it's very complicated. I've wrestled with that concept a lot over my life, because no one likes a judgmental person, but I think the reason they don't like judgmental people is because they're not very judgmental of themselves at the same time.
I think that that's actually in the definition of somebody who's judgmental intrinsically, is that you rarely look at people that are exceptional examples of how to live or how to be, who hold their colleagues and their friends up to the same standard that they hold themselves up to, and are like, that's a really judgmental person. The judgmental person is the one whose own life seems to be in chaos, who then goes around and is, pointing the finger at others. I think that might
It's like
be
a
part
glass
of it.
houses, stones kind of thing.
Yeah, I think so. It's interesting how all of this is really codified in our language and our proverbs already.
Yeah.
Yeah, no, I agree. I think, though, your point earlier that we, do want to look at our performance and see if we can improve. And the issue is, can we do that without having any self-judgments about it? Some a negative emotion. So it's just simply matter-of-factly noticing, for example, you're playing tennis, and my grip was wrong. My swing wasn't quite exactly right. There's no reason to put some kind of, I'm a bad person, I'm an idiot. There's no reason. I just notice, okay, my technique was wrong. End of story. Change the technique, and there's no judgment. There's merely correction, but without judgment. And I think that's an important. This the emotional side of judgment. That's the really painful part.
It's like not scarring yourself in the process of reorienting yourself, something like that.
Right.
Yeah. Wow.
I mean, as always,
yeah.
you leave us with so much to think about and so much to carry out into the world. And I'm really grateful for your work and for the time that you give us.
Thank you. Thank you again for inviting me to talk with you. It's a great pleasure and privilege.
Thank you so much.
Let's do it again down the road. It's really I really appreciate you, and I feel like I've come a lot closer to understanding the value of your work today too, and so I thank you for helping me understand, and I'm sure everybody will have lots of questions, so we'll see what people think too down the road.
Very, very good. Okay, and
But-
I'd love to talk again. That would be great fun. Absolutely. Thank you.
All right, we'll catch up
All right,
again.
yeah. Well, good luck with your meeting with your collaborators today, and keep moving this thing up the mountain.
Okay, take care. Okay,
All
thanks a lot. You too.
Thanks, Tom. Take
Bye.
care. Bye, everybody.